Howdy, this is Professor Shannon Gracie from Maricosta College. Today we will be working with learning how to factor out the greatest common factor and then also factoring by grouping. Very, very important skills for your future math life. Again, we are using Robert Blitzer's Introductory and Intermediate Algebra for College Students text. And here we go. So after you're done with your homework, you'll be able to factor the greatest common factor, which is denoted GCF, factor out the GCF of a polynomial, and factor by grouping. Factoring by grouping is a hugely important skill, especially when we are learning how to factor trinomials. Right? So let's warm up, pause the movie, and we'll see how you did. On your mark, get set, go! You can do it. Alrighty, let's see how you did. Now remember, we need to distribute that x squared throughout. So we get x squared times 7x to the fourth, and then minus 8 times x squared. This will yield a result of 7 times x to the 2 plus 4 minus 8x squared, which gives us 7x to the 6 minus 8x squared. Now when we're factoring out the GCF, we're going to start with something like what we just boxed, and we're going to write this, what we started with, the x squared times quantity 7x to the fourth minus 8. Alright, so next up, dividing. This is it. We're dividing a binomial by a good monomial. So this is equivalent to 16x to the fourth divided by 4x squared minus 8x squared divided by 4x squared. This gives us 16 divided by 4 is 4. And then we'll have x to the 4 minus 2. 8 divided by 4 is 2. And then we'll get x to the 2 minus 2. And then coming up here, we will have 4x squared minus 2x to the 0, which is 4x squared minus 2 times 1. Remember, anything to the 0 power is 1. So we get 4x squared minus 2. So how'd you do? Great. I knew you could do it. All right, on with the show. Factoring a polynomial containing the sum of monomials means finding an equivalent expression that is a product. So what we were doing in chapter 5 for a big portion of chapter 5 was we were going from a product, right? A monomial times a binomial, monomial times a trinomial, polynomial times polynomial, and we were rewriting it as a polynomial in standard form. So now we're going to take a polynomial that's in standard form, which is a sum or difference of monomials, and we are going to take that and write it as a product. Okay? All right. Here we go. Factoring out the greatest common factor. We use the distributive property to multiply a monomial and a polynomial of 2 or more terms. When we factor, we reverse this process. So we're using the distributive property backwards, and we express the polynomial as a product. Okay, so let's take a look. Remember, the distributive property, we're using A times B plus C in parentheses, and that was equal to A times B plus A times C using that distributive property. So here, if you take a look, you would end up, let's look at an example. Let's say that we had 2x times 3x plus 4. The A in this case, so you've got your A, so the A is 2x, the B is 3x, and the C is 4. So then we would get 2x times 3x plus 2x times 4. That's how we used the distributive property in order to multiply a monomial with a binomial in this case. So here's my C, and here is my B. Now, but what we're doing with the factoring is, instead of starting with A times quantity B plus C, we're starting with A times B plus A times C is equal to A times B plus C. Okay? So we're starting with this format and we're ending with this other format. So here we go, another example. Suppose that we had three x times 3x plus 3x times 4. Well, that would be written as, my A in this case would be the 3x. So we would get 3x, and then what would my B, which term is my B, or which factor is my B? Good. This 3x represents the B, and then plus 4 is the C. Now, this of course was a nice problem because what I gave it to you with the greatest common factor already written out like that. What you would normally start with in this problem is you would have 3x times 3x is 9x squared. 3x times 4 is 12x, right? So you would take this and write it like that. But in order to do that, you have to learn what is my greatest common factor. Okay? Okay, so let's check it out. In any factoring problem, the first step is to look for the greatest common factor. The GCF, which is greatest common factor, is an expression of the highest degree that divides each term of the polynomial. The variable part of the GCF always contains the smallest power of a variable that appears in all terms of the polynomial. Okay, so we're going to start out in the shallow end of the pool. All right, first we're just going to be given two monomials. Notice that we haven't joined them by adding or subtracting them to make them polynomials. And we're going to figure out what is the GCF. All right, so make sure you don't put an equal sign because we're just identifying the GCF. So here, let's take a look at these. Take a look at the constants. What is the largest number that divides both 5 and 15? Good, 5. Now look at the variables. There's no variable in the term 5, and there's an x to the 1 in the term that has 15 times x. So we need to, the greatest common factor is just going to be the constant, because this 5 has no variable term or no variable factor in this guy. So therefore the greatest common factor in this case is 5. So 5 is the GCF. Okay, let's take a look at this one. Now, looking at the constants, -3 and 6, we can factor out, okay, there's two possible results. You could have said -3, or you could have said +3. I'm going to go ahead and factor out a -3, all right? And now, let's look at the variable terms, okay? So, there is an x to the 4th and an x cubed, right? So remember, what's the smallest power showing up in those terms? Good, it's x cubed. Okay? So -3 x cubed is the GCF. And if you take a look, -3 x to the 4th is equivalent to -3 x cubed times x to the 1. And 6x cubed is, I factored out, or 6x cubed, sorry, I factored out a -3x cubed. So if I multiply that one times, good, -2, I get something that's equivalent to the original. All right, so here we go. Let's take a look at this last one. So let me box these results so you know what is the final answer. And you guys try the next one and see if you can do it. And pause the movie and check your work. All right, let's see how you did. Now let's take a look. This is a little bit of a sucker problem here. Take a look. There's a 1 in front of x squared times y. So what is the largest number that divides 1, 7, and 14? Good. It's just going to be 1. All right? So the GCF for the constant portion of it is, you could write a 1 if you wanted to. Then the variables. The first term has x squared y. The second term has x cubed y. And the third term has x squared but no y term. So what can we factor out? What is the smallest power of the common variable? Good, it's an x squared. So 1x squared is the GCF, but that of course is just equal to x squared. Alrighty, so here we go. Here's some steps for factoring a monomial from a polynomial. Determine the greatest common factor. Of all terms in the polynomial. Express each term as the product of the GCF and its other factors. And then use the distributive property to factor out the GCF. Okay, so let's take a look. What is the GCF of this one? If I was writing this guy, I could write it as 9 times x plus 9 times 1. Now, remember, we're using a times b plus a times c equals a times b plus c. And these are the a's. And then b is here and c is here. And of course, you know, you can have more than a binomial. It could be a trinomial or more. That's okay. So let's take a look at this one. What would you say that the a is? The a, also known as the greatest common factor in this case, is good, 9. Right? The b is x and the c is 1. So here we go. My a is just going to show up the one time, and then I'll get my x plus 1. And so see how it matches up? So take a minute and look at that and see what you think. Okay, pause the movie and do part B. See how you do. Your mark, get set, go. All right, let's see how you did. The greatest common factor of 32x and 24. So here we go. Let's work with the constants. The largest number that divides 32 and 24 is? Good, it's 8. Now look at the variable. I've got an x to the 1 and I don't have any variable at all in the second term. So the only thing I can factor out is my 8. So now I need to write 8 times, good, 4 x's is the same as 32x. And then minus 8 times 3 is the same as 24. So, again, do you see that here's your a, your greatest common factor, the b is here, and the c is here. So now we just use the distributive property backwards and write it as 8 times 4x minus 3. All right. And of course, you know, remember we can also use the, whoops, I used this rule here. This is another version of the distributive property, which is what we used in this problem since there was a minus. Okay. How'd you do? Awesome. Okay, so part C, notice that we have a trinomial. And if you'd like to pause it, I'm going to go ahead and work part C and D. If you want to pause it and try it yourself first, that's fine. All right, so let's take a look at the constants first. What number is the largest number that will divide 18, 12, and 24? Good, 6. And let's look at the variables. So we have an x cubed, and an x squared. What is the smallest degree represented? Good, x squared. So that means that x squared is the largest term for x that will divide each of these monomials. And then what about the y's? We have y squared, y, and y. So y to the 1 is what we pull out for the y portion of the greatest common factor. So 6x squared y is our greatest common factor, and that is going to be the a in our distributive property. So now we have to just match them up. 6x squared y times what equals 18x cubed y cubed? Well, the 3 times 6 is 18. X squared times, good, x is x cubed. And y to the 1 times y to the 1 is y squared. So when we multiply those guys together, we get the first monomial. Okay, now we got to rewrite our GCF, the a. So 6 times what is 12? Good, 2. X squared times x is x cubed, and I've already got that y represented. All right, next up. 6 times, good, 4 is 24. And then I already have the x squared y, so that's the only thing that I need to multiply 6x squared y by to get 24x squared y. So here's my a. The GCF is my a. Right. And then this time I have a b, a c, and I'm also going to have a d. In this case, I've got, a trinomial this time. So the a is represented outside the parentheses. And then we'll have our b minus our c minus our d. And we'll be all done. So how'd you do on that one? It'll come, don't worry. You'll get it. Okay, and then that's our end result. So notice that we have taken a trinomial, right, and we have written it as really a monomial, because we have a monomial times a trinomial, so that's a single product there. Right? Okay, so next up, here we got to be careful. A lot of times people want to multiply out, use the distributive law to multiply these terms. But if you notice, if we commuted the terms, our a this time, our part of our a is the x plus 1. Notice we can pull a 7 out, okay? And so here, the GCF is actually 7 times x plus 1 is the GCF. And I won't highlight it there. Okay. There's my 7. Now, I need to multiply this times 1 to get my first term back. And you got to be careful about that, because that's where a lot of people have trouble. They forget to put that 1 sort of as a placeholder. That's actually going to be our b. So then, plus our GCF again. And now, 7 times what is 21? Good, 7 times 3. And I got to match this x, okay, because it's not represented yet. So if you kind of picture that, do you see you've got an equivalence to the original expression? So this is my a. This is my b, and this guy is my c. All right, and so always make sure when you're factoring out a binomial, which is what we did here, we factored out an x plus 1 as part of our GCF. When you do that, you need to put parentheses around that binomial. Okay, so the a is 7 times quantity x plus 1. And then the b is 1, and the c is 3x. So that one was a wee bit tricky, but that's okay. All right, next up, that was sort of an intro into factoring by grouping. So the steps for factoring by grouping are, we group terms that have a common monomial factor. There will usually be two groups. Sometimes the terms must be rearranged. Factor out the common monomial factor from each group. And then you factor out the remaining common binomial factor if one exists. So let's take a look at some problems. All right, so factor by grouping. So what you're looking at here, you got, let's take a look. You've got a red group and a blue group. Okay, so here we go. From the red group, what could we factor out? What do both of them have? Good, they have an x to the 1 power. So what's left over? X times x equals x squared, and x times 3 equals 3x. Okay. All right, so now what can I factor out from the blue group? And you have to include the sign. All right, so if you factor out a positive, you put a plus sign there. If you factor out a negative, you put a subtraction sign, a minus. So good, we could factor out, so this here is equivalent to the red group. And the blue group, we could factor out a positive 5, and we're left with, good, x plus 3. So here's our blue group. So let's talk about what happened here. We went from 4 terms, okay, 4 terms, to 2 terms. And these 2 terms have a common binomial factor, do you see, of x plus 3? So when we factor out that x plus 3, remembering to put it in parentheses, okay, what are we left with? We're left with our x, because x times x plus 3 equals the red group, and then plus 5, because 5 times x plus 3 equals the blue group. And you're all done. Now, you may have noticed that you could have combined like terms here, but this technique is really the ideal way to factor trinomials. I just can't emphasize enough how important this skill is. So a lot of you have learned, you know, factoring by trial and error in the past, and that's fine. But trust me on this, try using the factoring by grouping, and I think you'll be more successful with all factoring problems. Okay, so go ahead and try part B. Pause the movie and try part B and see how you do. Okay, let's see how you did. Here's our red group and our blue group. So from our red group, what can we factor out? Good, an x squared. So x squared times x gives us the x cubed, and then x squared, you know, minus 3 times x squared gives us the second term, minus 3x squared. So that is our red group. What can we factor out from the blue group? A positive 4, and we're left with, good, x minus 3. Now you might be catching on that if you did this right, or if you're able to factor, you know, the in this case 4-term polynomial, then you'll end up with a common binomial factor. So when we factor out the common binomial of x minus 3, do you see that x minus 3 times x squared gives us the red group, and then x minus 3 times 4 gives us the blue group. So this is what we factored out, and then the remaining are like your b plus c from before. You see that? If you need to, I'll highlight. So the b in this case was the x, and the c was the 5. In this case, the b was the x squared, and the c was the 4. And then, of course, our a is that x minus 3. Right? That looks a little funny, but it's not bad. Okay, part C. Again, we have our red group and our blue group. So here we go. Do you see we can factor out an x from the red group? X times y equals xy. And then minus x times 6 equals 6x. So this is our red group. And then our blue group will be factoring out a positive 2, and we're left with, good, y minus 6. Now sometimes you have to be a little trickier about how you factor, if sometimes you need to factor out a minus. You always want to be thinking about matching the binomial, right? So here we go. So our a, our common binomial factor, is the y minus 6. Our b is the x, and our c is the 2. So we end up with y minus 6 times x plus 2. So here we are with our factoring. All right. And last but not least, in this example, we have, we'll try them as they are, red group and blue group. So what could I factor from my red group? I can factor out a 2 certainly from the 10 and the 12, and then think just an x. And I'll be left with 5x minus, I think, 6y. That's my red group. And then my blue group. Good, we could factor out a 7y, and I'm left with 5x minus 6y. So, do you see we have our common binomial factor here, 5x minus 6y. So we factor that guy out. And then my b is 2x and my c is 7y. So here's my a times quantity b plus c. Okay. Now, guys, it's important to do the homework for this section as soon as you can after the lecture so that you can get it all squared away. The factoring can slip away from you if you don't get it nailed down right away. So here we go. Let's try it as it is. We might need to rearrange terms, but we can try it out as it's written. So if you notice in the red group, the only thing we can do is factor out, I guess, a 1, and then we have x cubed minus 5 left over. And then let's take a look at what factors out in the blue group. So that was my red group. The blue group, I could factor out a 2 and a y, 2y. And then I'm left with, oh, it might work, x cubed minus 5. Wow, that's surprising. I wasn't expecting that one to work out. So here we go. Our common binomial factor is the x cubed minus 5. This is my b, and this is my c. So then we'll get x cubed minus 5 times 1 plus 2y. We're all set. And just so you know, these are the more complicated, sort of the factoring on steroids, I guess, or the beginning factoring on steroids. All right, so let's go down to part B. Now notice that here in part B, what do you notice? We've got more than two groups, don't we? I mean, if that's our red group, that's our blue group, we're going to have a green group, and hopefully we'll be factoring out the same binomial from each group. So in the red group, we can factor out 7x to the 4th, and you see we're left with x minus 1. So that's our red group. Our blue group, we can factor out an x squared, and we're left with x minus 1, so this might work out. And our green group, we can factor out a positive 3, and we're left with x minus 1, looking promising. So notice we have a common binomial factor of x minus 1, so that's going to be our a from the distributive property. This will be our b, our c, and then again we'll have a d in this case. So we will get x minus 1 times 7x to the 4th plus x squared plus 3. So guys, make sure that you always keep the signs in front of them. The main mistake people make with factoring by grouping is that instead of putting a plus x squared here, they just put x squared, and you got to have that sign so you know what goes in there. And then we had this guy. And we're all set. So, coming up here, let's take a look. Well, there's only, 3 terms, so I think part of the factoring has been done. I mean, do you see, this is going to just be a kind of a GCF problem. So here we definitely have an x plus 2 in all the terms. Do you see the x plus 2, and x plus 2 factor? Now let's look at the constants. We have an 8, a 10, and a 2. So I can certainly bring out a 2. And then I have an x to the 5th, an x cubed, and an x squared. So x squared will divide all the variable terms. And then I'll put some, well, we'll be fine. Okay, so then when I do the parentheses, well, you know what, we'll just kind of go back. This one's a bit complicated. So now I need to match. So this here is my GCF. This is my A. Okay. Okay. So here's my A. And then what do I need for the rest of it? I need a 4 to get 2 times 4 is 8, and then I need an x cubed. Good so far? So then, let's see, minus 2x squared times x plus 2. And then to match the 10x cubed, I need a 5 and an x. And then minus 2x squared times x plus 2. Now to match that, I just need to multiply it by 1. So this was my GCF from the terms. And here's, so that's my A, and here's my B, my C, and my D. So factoring out, so just using the distributive law backwards, I've got 2x squared times x plus 2. And then I've got my 4x cubed minus 5x minus 1. Don't forget about that minus 1. So this was my A, my B, my C, and last but not least, my D. How did you do on that one? Don't worry, it'll come. All right, so then the last one from this example, let's take a look. Is there anything in common between the constants 12 and 25? No, right? What about variables? Any common variables? Nope. So you know what? This one is prime. That's all you write down. It can't be factored anymore. It's prime. Okay. All right, good. Okay, and then we'll be wrapping this lesson up with a little application. So an explosion causes debris to rise vertically with an initial velocity of 72 feet per second. The polynomial 72x minus 16x squared describes the height of the debris above the ground in feet after x seconds. So here we go. Find the height of the debris after 4 seconds. So the polynomial was 72x minus 16x squared at x equal 4, because remember it's in 4 seconds, we get 72 times 4 minus 16 times 4 squared. 72 times 4 is 288. And then we'll have 16 times 16, which I believe is 256, right? You guys will have to check my math on this. Yep, 256. So we get 288 minus 256, right? So we get 8 minus 6 is 2, 8 minus 5 is 3. So 32, and then it was in feet. So after 4 seconds, the height of the debris is 32 feet. All right, now let's factor the polynomial. So remember, 72x minus 16x squared. If we're factoring, then let's see. So let's see the largest number that goes into 72 and 16. So I think that'll be maybe 8. I think it'll be 8, because 16 doesn't evenly divide 72. So we've got an 8, and then x to the 1 is the smallest degree of the common variable. So 8x times 9 gives us 72x, and then minus 2x, so 2x times 8x is 16x squared. So this is factored. Now what we want to do is compare these things, right? I mean, if we factored correctly, then we should get the same result, right, when we plug in 4 to the factored form. So we had 8x times 9 minus 2x, I believe, is what we just got. Double check. Okay. And then at x equal 4, we'll have 8 times 4 times 9 minus 2 times 4. So we're plugging in 4 for x. That's going to be 32 times 9 minus 8, which is 32 times 1, which is 32 feet. Right? So hopefully this exercise will help you believe that the factored form and standard form of a polynomial are equivalent expressions. All right? Have a fabulous day. Do your homework. Bye.